In this video, I want to talk about prediction using logistic regression and cost functions for prediction. So here's our basic setting. We have some data, x, and we're trying to predict the variable y. So for case 1, it would be x1 and y1. So let's set up an example of the data. So let's say that we already fit our logistic regression model, so we already have a beta, and we compute our xi betas. Let's imagine that the values for yi are set up like this. So maybe this is going to be a 1, maybe this is a 0, and this is a 0, and this is a 0. So by default, the way we do prediction is like that. We say that the prediction for yi is going to be 1 if pi I is greater than 0.5, and otherwise it's going to be 0. So note that that's the same as saying if xi beta is greater than 0, and this is xi beta smaller or equal to 0. That's because when xi beta is equal to 0, this expression is equal to a half. This expression is going to be greater than a half when xi beta is greater than 0, and this expression is going to be smaller than 1/2 when xi beta is smaller than 0. So let's do the prediction. So here xi beta is greater than 0.5. That means that the prediction is going to be 1. Here the prediction is going to be 1 as well. Here xi beta is negative, so the prediction is going to be 0, and here the prediction is going to be 0. Now, one thing we might be interested in is the cost of those kinds of predictions. And this would be the classification cost. So what would the classification cost be in this case? Well, here the prediction and the actual data match. So for this case, the classification cost is going to be 0. Here the predictions don't match, so the cost is going to be 1. The predictions match, so for this case, the cost is 0, and here the cost is 0 as well. Ordinarily, what we do for the classification cost is we take the entire data set and we average the classification cost. So the average classification cost in this case is going to be 0.25. Now, note the interpretation of the cost here. So here it's a 0 if the prediction matches the data, and it's a 1 if the prediction does not match the data. That means that what this is the misclassification rate. So, like we mentioned in class, this is computing exactly the misclassification rate. Why is that? Well, because the inputs here are r, the r's here are the true y's, and pi, the pi's here are those pi's. So what we're asking here is for each r, so for each yi, is the difference between the yi and the pi I greater than 0.5? So let's reimagine the data here. So what would it be? It is saying here the r's are the same as the yi's, so they're going to be 1, 0, 0, and 0. And the pi's are going to be the logistic of those xi betas.